to start, we need to first align what is the difference between hazards and error traps. In the guidance, you will see the term error-producing conditions. I use the term error traps when we work globally. That term is perhaps more common in the companies that we work with, but we mean the same thing. Other terms that you may come across is performance shaping factors, performance influencing factors. They all pretty much refer to the same thing. And so let's start with hazards. Hazards can be defined as anything with the potential to cause harm. And here we built on the research that looked into so-called hazards as energy. There is a school of thought based on the scientific research showing that injury happens when the amount of force or energy that the person is exposed to is bigger, there is more of it compared to what our body can withstand. We interface with energies all the time, with forces all the time, every time we interact with physical objects or substances, and it's the amount of that force or energy that cause harm. There is I won't go into detail. There is that world in itself. It can be calculated into kilojoules, but practically speaking, there is this list of 10 energies that are served or are used as a set of keywords to help identify those sources of energies. And these energies, the research shows that using those keywords increases the number of identified hazards between 30 to 50%. So it's a very effective way of identifying more hazards compared to when we don't use that list. And then we can compare that with error traps or error-producing conditions. Those are the things that increase the likelihood of error. Yes, they also can reduce the likelihood of error. That's fine. Here, again, I'll keep it simple. And so those can be the procedure that is out of date, the training that didn't cover the skills that were needed, or the tools that were not available, or the equipment that is confusing. We'll show you a number of examples. And then people need to deal with these challenges when they do the work, and so they do so through those conditions can lead to error, or they may lead to adaptation. So for example, if the procedure is unworkable, workers can develop their own procedure. Or if the tools are not helping, or there is not the right type of tool, they may fabricate their own tools, and sometimes those adaptations are unhelpfully labeled using judgmental language. But it is a form of dealing with those conditions that make the work difficult. And so now let's start with a simple example. So you see those two cans, and one is a cooking spray and one is a lubricant. Now imagine you are cooking a dinner for your family, and these two cans stand next to your cooking hob, and let's try to analyze the risk. So if we think of a hazard, so what would be the hazard here? If we think of something with the potential to cause harm, what is causing the harm? It's it would be the lubricant chemical if ingested. Then that could be the hazard. Now, what could be the potential error in our scenario? The error being, oops, I didn't mean that, would be a person takes and uses the lubricant spray for cooking. And then what would be the error traps or error producing conditions? So conditions that produce or create error. Here in our case, that would be spray bottles that look very similar. That visual similarity is a factor that significantly increases the likelihood of error. And this design consists of color, font, logo, black line, positioning, etc. So this is a simple everyday example. Now let's have a look at the industrial example. This is an illustration based on a photograph. Here you see a worker operating a control panel. And again, we can ask, what are the hazards? And we could see electrocution, hand entrapment, burn, hearing damage, potentially pressure release. Okay. But when we then ask, but what increases the likelihood of this worker making a mistake and pressing a wrong button? We'll see that the pipes are in the way, and they constrain the movement, and they reduce the visibility. And the color of the buttons, mainly red and green, if this person has a medical condition of color blindness, they will not see the difference between those. And it's middle of the night, and this should be a two-person job, but their colleague was called to a different job. And the work instruction does not actually cover how this should be done, and the radio to the control room is broken. So we see those different conditions we see on the right-hand side. It's difficult to classify them as hazards because on its own, they do not have the potential to cause harm in the same way as the hazards, as the energies do. And yet, you probably see how they increase the likelihood of failure. And so now what we can do, and that's opportunity that our guidance brings, is to learn how to identify those conditions before they lead to or contribute to a problem or an incident. And when we look at the risk assessment process, in the UK, there is a foundational process called 5 steps to risk assessment, which is identify hazards, then assess the risk, control the hazards, record, and review. And that's good. And that works well for hazards. But we need to expand that to now focus on identifying those error-producing conditions and the potential errors, and then give some thought to how we can address those and control the risk associated with that. And so now, while we can identify hazards, just looking at the exploring the workplace and the work and looking, oh, here we've got electricity, here we've got something else. It's very difficult to do that for human error or non-compliance or human action, because the potential risk is associated with a step. So people doing something and interacting with something, interacting with this control panel, with this lever, with reading this gauge. And so here, overall, trying to talk about errors generically is not very effective. It's much more effective to do that focusing on specific steps. And so here, now we can identify the steps, and then for each step, we can explore the hazards or potential forces and energies and the potential error traps and error-producing conditions that may lead to or that may create error or non-compliance. And so let me show you some examples. So here we've got a task of emptying a chemical tank. And step 3, so here we've got an extract. Step 3 is to close the valves and disconnect the hose, and the hazards are chemical leak and burns. And this is based on real risk assessment, and the controls were forklift training. This was training, chemical awareness, and a spill response procedure. But now when we added the 2 columns, you see, so the error traps and the error traps controls, and we engage with the technician doing this work about what makes this work difficult, we've learned from them that they may disconnect the hose before closing the valve. So this is the potential error. And why is that? Because there was no visual indication if the valve is closed or open. And technician may think the valve was closed while in fact it was open, and that could lead to a spill. And with that insight, then we could think about how we could prevent this error. And in this case, that company decided to redesign this connection to make it impossible to disconnect the hose with the valve being open, plus added the visual indication if the valve is open or closed. But that redesign and adding the engineering solution eliminated the risk of the error and mistakenly disconnecting the hose with the open valve. But what you see is important here is this insight, this aspect of risk was not visible to those who did the risk assessment before. And therefore, that means that the risk profile and the calculation of the likelihood that was conducted also did not reflect the actual risk. The actual risk was higher than the team believed because they did not see those aspects of risk related to error traps. Here is another example. So working on an electric panel. And here the step is to identify which circuits the person should work on. And the potential hazard is electricity leading to shock, burn, or arc flash. And when we look into the error traps and ask the person what makes identifying the circuits difficult, we've learned that the labels on the circuit are faded off and were not readable. And so that increases the risk. And then in addition to the popular controls that you would expect, we were able also to minimize the risk associated with that error by both replacing the labels, using the material that doesn't wear off in these conditions, and then also color matching the circuits on the plant with the circuits on the drawing. And again, for the risk assessment that focused only on hazards, the risk that was associated with the error traps in place was not visible, and therefore that led to a belief that the risk is lower than it actually was.